students, today our topic will be convex mirror. We have already studied the concave mirror and drawn the needed ray diagrams. So this is a very small topic. So to start with the topic, this is the convex mirror. So we will quote this surface. So we know that this convex mirror has been derived from a hypothetical sphere. So we know the center of the sphere is called as the center of curvature. We denote it by C, and the midpoint between the center of curvature and the pole is called F, focal point. We have already described this detailedly in our first and second videos. So today we are going to draw the ray diagrams. In a concave mirror, we know that the focal point and the center of curvature lie on the reflecting surface, not on the mercury surface. It is on the reflecting surface. But in a convex mirror, the focal point and the center of curvature are on the non-reflecting surface, that is the mercury surface. So we'll see what happens to the rays. Okay, the first theory says that a ray, if I project a laser light on the principal axis, if a light ray travels on the principal axis, along the principal axis, what will happen to it? Same as the concave mirror, it returns back through the principal axis, along the principal axis, through the back through the principal axis. The second theory is, if a ray travels parallel to the principal axis, what will happen to the ray? Parallel to the principal axis. We know in a concave mirror it will go through the focal point, but here this is a convex mirror. Convex mirror is a divergent mirror. So what will it do? It will diverge the light ray. It will diverge the light ray as if it is emerging from focal point. That means the ray which comes parallel to the principal axis will get diverged. But whether it is going this way or this way is decided by the focal point. Therefore, from the focal point we draw a dotted line towards this, and from here we draw the straight line. So that means the parallel ray comes parallel to the principal axis and gets diverged to this direction. That is the second theory. Yes. The third theory says, if a ray comes towards the focal point, what happens to it? So we'll draw a ray which is coming towards the focal point. Towards the focal point. What happens to this ray? At this point it will get diverged, and that will travel parallel to the principal axis. So second theory and the third theory are vice versa, traveling parallel to the principal axis and getting diverged as if going away from the focal point, and here traveling towards the focal point and getting diverged and traveling along the principal axis. That is the third theory. And the fourth theory states that if a ray travels towards the center of curvature, that means I'll draw it here, travel towards the center of curvature as if going to the center of curvature, but it does not go, because at this point it will get diverged. What happens to this ray? If it travels towards the center of curvature, it is returned back in the same pathway. Like when it travels on the principal axis, along the principal axis. Towards the center of curvature, travels back along the center of curvature. That is the fourth theory. And the final theory is when a ray travels towards the pole point. Even in the concave mirror it is the same thing. When a ray travels towards the principal pole, then it makes an angle with the principal axis. That we can call as incident ray. Here, this exact point acts as a plane mirror. This situation, it acts as a plane mirror. Therefore, if a ray comes towards this pole point, it will get reflected back if it is making an angle with the same angle. Incident angle, this is reflected angle, incident angle equals reflected angle. So this ray will be reflected back with the same angle. So these are the 5 theories related to the convex mirror. But after drawing all the theories, you will be confused. Therefore, each and everything I will draw it separately. First one, convex mirror traveling along the principal axis and coming back along the principal axis. Yes, first theory done. Second theory. What does the second theory say? Second one, parallel to the principal axis, getting diverged as if going from the focal point. Parallel to the principal axis, diverge as if going from the focal point. Third theory states, the vice versa of this. If a ray travels towards the focal point as if going to the focal point, what will happen to that ray? It is as if going to the focal point, but it will get diverged and travel parallel to the principal axis. That is the third one. Then the fourth one is this situation, traveling towards the center of the curvature. So I can draw it in this way. Focal point, center of curvature, and a ray traveling towards the center of curvature. As if going to the center of curvature, it will get reflected back along the same pathway. Towards the center of curvature, along the center of curvature. And the final one, convex mirror. This is the pole point. If a ray makes an angle with the principal axis at the pole point, at this point the mirror will act as a plane mirror and reflect the ray back with the same angle. Incident ray and reflected with the same angle. So to summarize all 5 theories, along the principal axis, goes back along the principal axis. Parallel to the principal axis, getting diverged as if coming from the focal point. Towards the focal point, getting diverged parallel to the principal axis. And towards the center of curvature and along the center of curvature. Back the same pathway. And here at the pole point, if it makes an angle, it will be reflected back with the same angle. I hope you have understood all 5 theories. With these 5 theories, we can draw the object and the location of the image. So please copy these down. Now we are going to keep an object and get the image. Yes, we have done the same thing in the concave mirror. There, when placing the object, because the focal point and the center of curvature was there, we had many locations. That means in between pole and focal point, at the focal point, in between focal point and center of curvature, on the center of curvature, beyond center of curvature, all those points were there. But in this situation, on the reflecting surface, we do not have any such location. Therefore, this is a very easy one. Wherever we keep the object, the image characteristics will be the same. So, we have only very few theory here. Object here. Yes. There will be thousands of light rays emitted from this object. We know that from a luminous object, light rays fall on the non-luminous object. From there, light rays are emitted. So, we'll select this point. And from here, also there are many rays going. We will select the ray which is going parallel, because our ray should be within these 5 theories. If we go out of these 5 theories, we can't get the location. Therefore, we will follow this. So, here we will take the second situation, parallel to the principal axis. Now, tell me students, what will happen if the ray travels parallel to the principal axis? Yes, it will get diverge as if going from the focal point. Diverge. So, the real ray, what is happening to the real ray? Through the parallel to the principal axis, and as if going away from the focal point. The real ray is going this way. Yes. The second theory, the second diagram, that is, we'll use the fourth theory. The fourth theory says that if a ray is traveling towards the center of curvature, so we are going to draw that, towards the center of curvature, from here, towards the center of curvature, as if going to the center of curvature. I hope you all can see these are dotted lines and this is the real line. What will happen if a ray travels towards the center of curvature? It will get reflected back along the center of curvature. So the true line, real line is going this way. So what is happening to the real lines? This line and this line, they are just going somewhere here. Will they meet? No, they won't meet. So our normal theory, if they don't meet at this side, we'll try to make them meet at this side. Yes, here the dotted lines are meeting each other at one point, at the intersecting point. So this is the point. Therefore, the tip of the arrow will be shown here. So I am drawing a dotted image. Why am I drawing a dotted image? Because this image is not a real image. This image is a virtual image. Therefore, whenever you change the object distance or object size, you will get this kind of a image. So this is the object, this is the image. So what about the characteristics of the image? Yes, the first characteristic is that location. Where is the location of the object? Anywhere. Location of the image. Location of the image is always in between the pole and the focal point. In between pole and focal point. And the second one, the character of the image, it is a virtual image. We know that the character of the virtual image cannot be projected to a screen. We know in a projector we get some light rays. That projector, the light rays from the projector can be projected on the wall or a curtain or whatever solid object. But virtual images cannot be projected on the wall or a screen. Only real images can be projected on a screen or a wall. Therefore, this is a virtual image. If we look from this side, if our eye is here, we can see a small image here. Then the next character of this image is, the image is diminished. Diminished means this is the size of the object, this is the size of the image. The image size is smaller than the object size. Therefore, the image is diminished. And the next one, it is upright. The tip of the image object, this is the tip of the image. Both are in the same side, therefore it is upright. So we can see that whenever, whatever place or wherever, whatever height we keep the object, we get a similar image. So these 4 points can apply to any image formed by convex mirror. Therefore, these convex image convex mirrors are normally used in supermarkets. Now we have the CCTV in supermarkets, but before they did not have CCTV. Therefore, closer to the shopkeeper or closer to the cashier, there will be a small convex mirror, so that a large area can be seen by a small mirror, because large objects will be diminished and focused on the mirror. Therefore, for security purposes, they use convex mirror in supermarkets. And also to observe the surface, under surface of a vehicle, to detect bombs or such things, they use this convex mirror. And also on the side mirrors of certain vehicles, convex mirrors are fixed, so that a large area can be covered with this small mirror. Sometimes you might have noticed that in a mirror, it is sometimes written that the images formed and in this mirror is closer than the real object. So because of these principles, so a large area can be covered within a small mirror, therefore this mirror is used. Sometimes in junctions, in certain U-turn junctions, these mirrors are fixed. Especially if you are a Sri Lankan, you know that there is a place where there is 18 curves. It is called the Dahata Vangua. In the Dahata Vangua, in each curve, in each bend, they have fixed a convex mirror, so that the driver can observe a vehicle coming from the opposite direction. So I hope you all have understood this theory. So please share this video with your friends and subscribe to our channel to get more notifications. Thank you.